Now, next one is mathematical expectations of continuous random variable. So similarly, for when x is a continuous random variable with the probability density function f of x, then mathematical expectation of x is expected value of x equals to integration of x f of x dx. The limit is from minus infinity to plus infinity. So we can say this is the mean of the random variable of x. That's why this is mu. So we can write mu equals to e of x. As this is continuous random variable, that's why here we use the integration to get their summation. Now, if we consider one problem, real life problem, suppose that x is a continuous random variable with the probability density function f of x equals to 2x when x lies between 0 to 1 and otherwise the functional form is 0. That means if x equals to 2, then the value for f of x is 0. So now, if we want to find out the mathematical expectation of the random variable x, then how we can get it? By using this formula. We know mu equals to e of x equals to integration of x f of x dx. So that means integration of our limit is here 0 to 1. So 0 to 1 x, and the function here it is given as twice x. So x times twice x dx. So after doing this simple integration, finally we have the value as 2 by 3. So this is the value for mean or expected value of x. Now, more examples about continuous random variable. So see here, the pressure measured in pounds per centimeter squares at a certain valve is a random variable x whose probability density function is given here. So see, this is the functional form, and the value for x lies between 0 to 3, and otherwise the value is 0. Now our task is to find out the average pressure measured in pounds per centimeter squares of this valve. So again, we can do it by using the mathematical expectation formula. That means we can write mu equals to x, some integration of x f of x dx, where the limit is from 0 to 3. And after doing that integral part, we will have the average pressure for this valve. The next example here, see here, another example, continuous random variable x has the probability density function. Here we have different functional forms for different intervals. So that means when x lies between 0 to 1, then the functional form is half of x. When x lies between 1 to 2, the functional form is 1 by 4, 3 minus x. When it is 2 to 3, it is 1 by 4. When it is 3 to 4, it is 1 by 4 times 4 minus x, and otherwise 0. So similarly, if we want to find out the average of x, then the same formula. Expected value of x is integration of x f of x dx, where the limit is from 0 to 4. But here what we do, we will split them into these 4 parts. That means first part, integration of 0 to 1 x half of x dx plus integration of 1 to 2 1 by 4 3 minus x times x dx. Similarly, for third one, it is integration of 2 to 3 1 x 1 by 4, and for the last one, integration of 3 to 4 x 1 by 4 4 minus x dx. So after doing all this integral part, then taking the summation, and we will have the average value for this random variable x. So these are the examples for continuous random variable.